What does that mean when you say a linear equation? A linear equation is, nope, wrong marker here. If, that's how you know if the equation is linear. If each term contains only one variable, and that's not enough, to the first power. Or a constant. Or is a constant, if you want to write is a constant instead. I'll put is. That's really the definition of linear equation. Now let's take an example. xy plus 3 equals 7. Is that a linear equation? If each term, there's 1, 2, 3 terms. Only addition, subtraction separates terms. 1, 2, 3. If each term contains only one variable, let's look at this term. Does it have only one variable? No, that's not linear. Okay, let's try this one. 6x plus y squared equals 9. Is that a linear equation? If each term contains only one variable, yep, each one has one variable, but wait a minute, to the first power. Is this variable raised to the first power? Not linear. If I have 3x plus 2y equals 7, is that a linear? Yes. It is linear in two variables. It has the x and the y, each one raised to the first degree. It says you must have in each term, only one variable raised to the first power or a constant. That's a constant. So that's actually a linear in two variables. You could have a linear in 3, 4, 5 variables. I could have 7x plus 2y minus 3z equals 4m. That's still, each term has one variable to the first power. So that is linear. But how many terms you have there? 4 terms or 4 variables. If I have 3x plus 6 equals 0, is that linear? Yes, that's linear. And how many variables? One variable, one unknown. The linear equation with one variable, one unknown are easy to solve. But as the number of unknowns increases to 2 and 3, it's not that easy. By the way, if you have x's and y's in the bottom, is no longer linear. So if I have, for example, 2x plus 3 over y equals 8, that's not a linear. Why? Because you can write that as what? 2x plus 3y to what power? 3y to the power of what? -1 when you bring it up equals 8. To be linear, each term contains only one variable. Well, each one has only one variable to the first power. Is that power 1? No, that's not a 1. That's why this is not linear. So if you see x is in the bottom or y's, that equation is not a linear equation because the power is -1 now. This chapter deals with actually a linear equation in two variables, something like this. So we're going to spend the entire chapter looking at problems like these. You have linear equation with two unknowns in it, x and y. So here's an example. Given the linear equation, two x plus 3y equals 7. Given that, determine whether 2, 1 is a solution. If the point 2, 1 is a solution. So how do we figure if the point 2, 1 is a solution? What do we do? What do we do? Plug it in, sure. Every time you see x, put a 2. Every time you see y, put a 1. Does that equal to question mark? Does that equal to 7? If the answer is yes, that point is a solution. What's 2 times 2? 4 plus 3. Does that equal to 7? Yes. So the 2, 1 is a solution. What does that mean, that point is a solution? What that means actually, if I graph that equation, 2x plus 3y, if I graph that one, that point is going to be on the line. That's really what that means. Let's graph it and see. 2, 1. I need 2 points because that's a straight line. Linear equation is a straight line. All you need is really 2 points to graph it. Now, if I take the 2x plus 3y equals to 7, and I find the x and the y intercept, I should be able to graph it. So 2x plus 3y equals 7. If I want to graph that, let's find the y-intercept. How do you find the y-intercept? We'll do that shortly. You let x be 0. If x is 0, you have 3y equals 7. Y equals what? 7 over 3, like 2 1/3. That's the y-intercept. That's right here. How do you find the x-intercept? You let y be 0. You cover the y. The y is gone. You have what? 2x equals 7. X equals what? 7 over 2, which is 3.5. 1, 2, 3, 4, 3.5 is right here. When you connect these 2 points, that is the graph of 2x plus 3y equals 7. So the question what we ask you is the point 2 comma 1 on the graph. There's the 2 comma 1. Is it on the line? You can see from that picture, yes it is. That's why it's a solution. So 2 comma 1 is a solution to that problem. Let's try another one. Where the stuff might be used. Let's see where the stuff might be used. Examples. We are going to be dealing with 2 equations by 2 unknowns in this class, not just one. So you are going to be dealing with something like this. You're going to see an equation that looks like 2x plus 3y equals 6. Another equation might say 5x minus 4y equals 7. It says solve them. Well, before we get to the question of solving, I need to know, where do you come up with these equations? I'm not even going to touch these. I'm just going to show you that's where we're heading. We're going in that direction. So where do you get these equations from? What real life problems? Because people said to me, what am I going to use this stuff? What am I going to use it? So let's take an example. Is there a movie coming out soon? A good movie? What is that movie with, not Finding Nemo, the other one? Finding Dory, I guess, broke every record in terms of money. So let's say we go to watch that movie, Finding Dory. Tickets price for adults. Last time I've been to the movie theater, now I went to watch The American Sniper, but before that was Popeye the Sailor, so years ago. So I think the tickets for the American Sniper was what, $10 for an adult? I don't know if it's still $10 an adult. I don't go to movie theaters, I can't sit. And the kids, how much for the kids? Anyone? Let's say $6, $5, $6 sounds good. I'm not gonna do $5.50, let's say $6. Let's say we have a showing there, and the theater was completely packed. The theater can hold, how big these theaters? 500 seats? Do you think it'll be 500 seats in them? Is that too big? That's too big? 200 people? So let's say it was 200 people in that movie theater. 200 seats were sold. And when we counted the money from that showing, the total amount of money in the cash register was $8,250. From that one showing, $8,250. And if I'm the manager of that movie theater, I want to know how many adults were there and how many kids were there. Does anyone know how many adults and how many kids? No. But we can make equations out of them. I can let X be the number of adults. That attended that movie showing there. And I can let Y be the number of what? Of kids. I need to come up with two equations by two unknowns, two sets of them. The first one, I'm going to deal with how many seats were sold. If I take all the number of adults that went there and all the number of kids that went there, you add them together, that number should equal what? 200. So that's my first equation. X plus Y. We had 200 seats were taken. That's my first equation. The other equation deals with the money. Each adult has to pay how much money? 10. So if you have X of them, that's 10X, 10 times X. The money from the kids, each child has to pay what? $6, 6Y. The result is what? 8,250. And that's my two equations by two unknowns. How do we solve them? That's not today's job. That's not this video. That's the next one, next section. It will be today's job, but not this video. I just want to show you where the stuff might be used, you know?
I was going to ask, is it possible to get $1,250 anyways?
Is it possible?
Is it possible? 10 times 200 is 2,000.
Oh, yes. Why is that number too high? I got 20,000 when I multiply 10 times. Maybe I put two extra numbers. 125.
What's that?
750. And we'll make life easy. We'll say this is a big theater, holds 2,000. Yeah, that number's too high. Because now 2,000, if it's filled with adults, what's 2,000 times? Excuse me. That won't work either. Yeah, that will work. What's 2,000 times 10? 20,000. If you filled it with kids, what's 6 times 2,000? 12,000? That won't work either. What was I thinking then? How about 18,000? It's somewhere between 12 and 20,000. Yep. I did actually use the calculator, but I used this cheap calculator that's worth nothing. In my mind, I had 175 and 125 and 75. So 125 times, that's at the kids, times 6, that's 750. Add to it 75 times 10. Oh, I know what it did. This doesn't know the order of operations. That's why. Cheap enough, you can do order of operation on this one. Because the calculator is supposed to wait till I multiply by 10 first, then add the numbers. Multiplication before addition. But what do you expect for something that's worth about 3 pennies? You know? Not much, really. So it didn't know the order of operation. I'm supposed to wait. So we fixed that. Thank you. Yep. But that's how you come up with the two equations by two unknowns. Let's try another one. One day I'll bring a better calculator here. Oh, what do you mean? Wait. I might have one. I have one that for 6 cents instead of 3 cents. There's one a little bit better. I'll use that one. It's at least scientific. Let's take someone who is about to retire, because young people always said, why you want to put your money in something that gives you less interest? But let's say someone is retiring soon, not yet, and that person has $200,000. Now it sounds like a lot of money to somebody your age. 200,000 is a lot of money to you and me. But if you're retiring and that's all you got for retirement, you are in big trouble. So this person goes, you know what? I need to put the money. I can go put them in a CD, but the CD you locked in. You can't just take that money out till it matures, till that time. There's a penalty for that. So you CD here at Bank of America. And Bank of America gives interest rate, I don't know, this CD, good luck getting 4%, you'll never get that. But let's say 4% today. And the other portion of that money, I'm going to put them in bonds, U.S. bonds here. And let's say this one gives 6%. Now, usually people say, well, if you're getting 6%, why would you put 4% here? Maybe you don't trust the government to handle your money. Maybe you think the bond's going to collapse and I'm going to lose it. The bank is safer. Or maybe you want to have access to the money. Sometimes when you put them, especially in stock or somewhere, you can't touch the money till a certain age. So you want to have access to it. Or you just want to be diverse there. So you know what? I don't know if I trust either one. I'll put some in each one. And your goal, you say, you know what? My goal is to get interest at the end of the year equal to $9,600. That's what you want. Maybe you got a car payment, maybe you got a house payment at the end of each year of $9,600. Your goal to put that money in a bond and CD at 6%, 4%. So at the end of the year, you're going to collect $9,600 worth of interest. Let's see if that number is reasonable. If you put all that money into bonds, you'll get back how much? 200,000 times 0.06. 12,000. If you put them in CDs at Bank of America, you get back what? 8,000. Between 8 and 12, that's 9,600. So I'm okay. Makes sense. So the question, how much money are you going to put in each one? I can let X equals the amount of money we put in CD, and I can let Y equals what? The amount, I don't know why I have D there. Amount of money we put in what? Bonds. Can we come up with two equations here? Let's talk about the actual money itself. If you take the money you put in Bank of America with the money you put in bond, put them together, what are you going to have? 200,000. That's the first equation. Now, interest is principal times rate times time. Time here is going to be 1 year. Interest is the amount of money you put in times the rate, because T is 1. So if you take the interest from Bank of America, which is the amount of money you put in, which is X, times the interest rate, which is 0.04, you add to it the interest from bonds, which is the amount of money in bonds, that's Y, times interest rate 6% or 0.06, it should equal to what? 9,600. And that's my second equation. If I clean the second equation, this will clean to what? 0.04x plus 0.06y equals 9,600. So that's equation number 1. And this is equation number 2. we have two equations by two unknowns. I should be able to solve them. Now the question is, how do we solve these? Well, we're going to show you 3 or 4 different ways of solving these equations. One of them graphically. The other method we're going to do by substitution and elimination method. The third way of doing it, we're going to show you how to solve them using determinants. So maybe I'll do each one as a separate video.